I will give you a short introduction, who we are, what we are doing, what are our competencies. The second, I will give you a short, brief introduction to an exemplary project which we are carrying. And then, as a conclusion, I will present the team who is working on these projects and what we are looking for. Next slide, please. So, as a basis in our team, we combine different core competencies such as material sciences and mechanical and electrical engineering, as well as the infrastructure which we have in the Tambov State Technical University. This enables us to conduct the scientific research and the experimental development in order to develop different devices, materials, and systems. As you can see on this slide, next slide please. One of the main parts of our basis is the infrastructure which we have. A part of the laboratory with different modern equipment. We also have different reactors and equipment for synthesizing and creating different nanomaterials. So you can see those reactors and equipment here. We are using the CVD method for production of nanomaterials. Next slide please. Using this infrastructure, we are able to create different types of nanomaterials. One of them is so-called carbon nanotubes. Here you can see the different microscopy of nanotubes. We are able to create nanotubes with different parameters, such as the length of nanotubes, the diameter of nanotubes, and different functional parameters on the surface of those nanotubes. Next slide, please. So, fine. We have those nanotubes. What else? What should we do with them? And now I'm going to present you some ongoing projects in the university, in our team. So, as a basis, we take our infrastructure and the nanomaterials. In this case, these are carbon nanotubes. And we create so-called smart materials. Why are they smart? Because when we take nanotubes and combine them, or let's say we modify polymers with nanotubes, in order to give a new composite material some specific parameters. For example, using the electromagnetic field, we are able to manipulate or to regulate the internal heat field of the new material, which means that we are able to improve the efficiency of energy transmission through this material. So how can we use these kind of materials? Like, who actually needs these materials? So we can use them in order to create heat storages or, let's say, heaters. What is specific about this? So these heat storages, for example, on this picture, you can see different types of products which we can create using our smart materials. This is the heat exchanger. This is the protection system for breathing, and this is the magnetic fluid material. Why is it good? Because using the heat storage, for example, in this case, we are able to remove the heat when a person, for example, breath in, we are able to remove the heat when the person is located in a place where it's very hot, for example, during the fire, right? So this material helps to remove the heat. For example, this material, the magnetic material in form of fluid stuff, we are able to manipulate the internal heat exchange in this material using the magnetic field from outside, all right? And then we are also able to create different heaters. Here you can see two different forms of these heaters. One is kind of a panel, another is a cable. What is special about this? The special thing is that they can self-regulate the mode of, let's say, functioning of these heaters. What does it mean? For example, we take this panel, we install it in the body of car, and then, for example, we set the temperature which this heater has to maintain in the body of the car. And then, if, for example, somebody opens the door, or the outer conditions are changing, then this heater will change the consumption of the electric current, for example, and still keep the temperature the same. So this is, like, long story short, without any scientific definitions and so on, right? Next slide, please. Another ongoing project is using those different types of nanotubes, nanomaterials. We're able to create functional materials. So what is specific about these functional materials? These are normal materials or composite materials with improved electrical conductivity. Using these materials, we are able to create different devices. For example, supercapacitors, which look like batteries, but these are for a short period of time. So charging the energy, keeping the energy for a short term, and then giving the energy back. And then we have different protection